Layers of the atmosphere. So the layers of the atmosphere, let's start from the ground. So this here is the ground. And it goes several miles, kilometers up, but you don't need to know how many kilometers it extends or anything like that. You just need to know the layers and some features about each layers. So the first layer here is the troposphere. And so most of what we're concerned about actually happens here. Weather occurs in the troposphere, air pollution occurs in the troposphere, and greenhouse gases occur here. One of the things that you need to know is that in the troposphere, it's warmer near the ground, and as you go higher, it cools off. But then after that, there's temperature variations in the different layers. It's actually really hot up here in the thermosphere, but you don't have to know all the temperatures of all the other layers. What you need to know is just in the troposphere, it's cooler up high versus closer to the ground in temperature. The next layer you need to know is the stratosphere. And this is where the ozone layer occurs. And it's good, which protects us from UV rays. And you're going to learn how the ozone has been destroyed up here from chemicals, from refrigerants and things like that. But it is repairing itself. So ozone occurs in two places. It occurs in the stratosphere and in the troposphere. But up here, we want it. It's the same thing. It's O3. 3 oxygens. In the stratosphere, it's good to have it there because it protects us from UV rays. But down here, it's an air pollutant that causes us harm, and it's formed from a different process. So same gas formed in two different ways, and we want it in the stratosphere. We don't want it in the troposphere because nobody's up here breathing it in the stratosphere. But in the troposphere, when it's formed through combustion of fossil fuels, when we drive our cars and we emit NOx out of our tailpipe, and it combines in chemical reaction in the atmosphere, it turns into ozone, which is an air pollutant and causes us harm. And then the mesosphere, you don't have to know any specifics about the mesosphere. And then you have the thermosphere. And up here you have the exosphere, is really the boundary line. So I didn't put it as its own box because it's really kind of the boundary between our atmosphere and outer space. Okay, and so your satellites are orbiting the Earth, kind of are in, between the thermosphere and the exosphere up here. Mostly in the thermosphere. So satellites orbit here in the thermosphere, you need to know that. The northern lights, which is called the Aurora Borealis. If you've never seen that, Google it, it's pretty amazing. I've seen it once in Idaho, and it was very unusual to see in Idaho. Usually you have to be much further north in Canada to see it. Borealis occurred here, and sometimes also in the mesosphere. So the northern lights occur also in the mesosphere, but mostly in the thermosphere as well. So those are the layers of the atmosphere and the specifics you need to know about them. Going on to inversion layers. So Inversion layers happen when layers of the atmosphere do not mix. So normally in the atmosphere, our temperatures go from warm and they cool off. And it's just this gradual change from warm to cool. But sometimes layers of air can get trapped. So inversion layers occur when layers do not mix. Of air do not mix. And it's because of density, because of temperature. So it's because they're different temperatures, which equal different densities. Okay, and so this traps pollution. Air pollution. So below are a couple of different ways that this can occur. So we're going to draw here some different ways that it occurs. All right, so one way that it can occur, the main way that we think about, and this example is on most of the exams about this, but it's not the only way, is when in the summer, the sun is going to warm up the land, and warm air from land is up here. So the air is warm from a warm day. Okay, so this is warm air. Okay, so this would be like a coastal community. This would be like Santa Clarita. We're behind a mountain. Actually, we're behind 2 mountain ranges from the ocean. This would be like the parts of Los Angeles, like Santa Monica, that are right next to the ocean, Malibu, Ventura, Oxnard. All right. Well, in the late afternoon, this air is warm, and it's kind of warm all over. So it's like pretty much warm all over, right? Because it's a hot day. In the late afternoon, ocean breezes come in, and the water is cooler, and so it rises into these cooler breezes. So it's cooler than the air from land. So the air from land kind of moves its way this way, but the warm ocean breezes bring air this way. I'm sorry, the cool marine breeze. So we call it the marine breeze. So cool marine breeze in the late afternoon. So this marine breeze will actually kind of go as far as the mountains and sometimes push all that pollution up against the mountains. So like Pasadena is right up against the mountains, but there's no, so you have ocean and then Pasadena, and that's why sometimes air pollution is really bad there because it kind of gets trapped by that mountain. But here we have these layers. So we have cool air and warm air, and then above it is cool naturally. Because remember, as you go higher, you have cool air naturally higher. And so this is a density difference that is not going to allow the air pollution to mix. So if we've got air pollution from cars or other factories, power plants, in LA, it's mostly cars for the air pollution. That air pollution is going to rise and it's going to get stuck. And that is one way we have an inversion layer. Here's another way we have an inversion layer. So this is what more happens with Santa Clarita. So during the day, their warm air rises, and then naturally it's supposed to cool off in the upper atmosphere. Okay, so that's a normal situation. But the sun is normally overhead, but then as it starts to set, it sets over here off the ocean. That's why sunsets in California are pretty amazing, because the sun sets in the west, so it's gonna move this way. And so the late afternoon, the sun is gonna hit this mountain, and the mountain is gonna cast a shadow. Actually, I'm gonna do it like here. Okay, so we're gonna have this shadow down here in the late afternoon when the sun's at an angle as it starts to set. So 4, 5, 6 o'clock. And so this will be the late afternoon. And so now we've got it a little bit cooler. Now it still feels hot on these hot days. It's gonna feel marginally cooler, but it's enough to have a density difference. And so now you've got cool air, warm air, cool air. And so they're not mixing. And so the air pollution caused by cars or other things, they're gonna get trapped by that layer of warm air. So these are two ways you have inversion layers. There are others, but these are the two main ones. All right, you have to know some other weather events as well. So the next one you have to know is the lake effect. All right, so the lake effect is when snow is created from lakes. So this is more of what occurs in the Great Lakes, but you have to know this because you have to know what occurs around the country, not just in your own backyard. So the lake effect snow occurs when freezing air passes over a lake's warmer water. So remember that water has a high heat capacity, so it takes a lot more energy to warm it, and a lot more energy has to be released to cool it. So if you've got land is really cold, the water is not as cold. Whatever it is, the lake, the ocean, whatever it is, it's not as cold on freezing days. And the same in the summer, the beach water is nice and cool compared to the land in the summer. Okay, and that has to do with, again, with water's high heat capacity. And so what happens is that as the freezing air starts to pass over the lake, and we'll assume this is a giant lake here, like the Great Lakes, it evaporates and moves over land to snow. Okay, so as the freezing air passes, some lake water evaporates. Warms the air and moves away from the lake. All right, so that warm air, as it rises, is going to cool in the upper atmosphere, and then it's not going to be able to hold as much moisture, which is normal, and so it's going to snow. So after cooling, it basically dumps its moisture as snow. Okay, so let's draw this out. You can pause the video if you need to catch up. So this is warmer air here. So, I mean warmer, it's not warm air, so it's warmer air. Remember, this is all winter and places like Chicago, so it's not that warmer. And then we have an inversion layer that's going to be different temperatures. And so over here, we have the cold air coming in, and the cold air is going to cause some evaporation. And as the warmer passes, it's going to rise. Okay, so this is heat and moisture. And again, it's not like hot water. We're not talking about tropics. It's just slightly warmer, okay? And then as it goes back over land, it's going to cool down because the land over here is cooler. So we have cooler land over here. And this is a warmer lake. You can't really see that very well. So I'm writing here, warmer lake. I know it's hard to see. So warmer lake here and then cooler land here. And so as it cools off, you're gonna end up with snow. So that is the lake effect snow. And we're talking about big lakes that do this. So this is one of the reasons why Chicago gets a lot of snow. It's right on the Great Lakes. Now let's talk about the rain shadow effect. Again, pause your video if you need to catch up on your drawing. The rain shadow effect is another way that we get dry weather. So one of the reasons why we're very dry here at 34 degrees north is because of convection. The other reason why we're very dry has to do with the rain shadow effect. So what happens is this. We have warm, moist air rises off the ocean. It's not that warm. So, you know, in California, our ocean water is like cold-ish. So it's warm-ish. So I'm gonna make it orange because it's really not that warm, cool-ish. It's just warmer than other places. Okay, so we're gonna put up here warm, moist air evaporates from the ocean and travels inland. Okay, so as it travels, it's going to rise, cool, and condense into clouds. So it's going to condense because the air can't hold all that moisture once it gets colder. So as it's rising, it's going to cool down because it's getting higher in altitude, so it's going to cool down. Okay, so it's going to rise, and as it's rising, we're going to get these clouds, and it's going to rain. Okay, so here's our rain. And then the clouds are going to continue to move this way, but they've dropped all its moisture. So the desert and dry areas might see the clouds, but it's not going to rain. So again, cooler air can't hold as much moisture. Okay, so they're gonna dump most of its moisture on this side of the mountains, and so behind it is often an arid or dry location. And so we have here, well, it's not really a line. So we have arid, dry climate. So we have a lot of deserts that are formed from the rain shadow effect. We are behind mountain ranges, and we are chaparral, which is almost a desert, but it's not. close. And so again, a lot of deserts are found on the other side of big mountain ranges. Not all deserts, but a lot of deserts are found at the other side. And so that's one way that we get deserts, is from the rain shadow effect. All right, and so that's it for your atmospheric science notes.